Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2019 Test 5A Paper 2 Code C&D Physics. Let's move to question number 1. So in question number 1, a circular disk of mass m and radius r is hinged at point P so that it can rotate freely in the vertical xy plane about an axis passing through point P and perpendicular to the plane of disk. A small size insect of mass m performs motion along the horizontal diameter AB in this disk in such a way that disk always remains in rotational equilibrium. If delta t is the minimum time taken by the insect to reach from O, that is the center of disk, to B, then find the value of delta t. So in this case, let at any time t the particle is at this position and its distance from point O is x. So if I draw the free body diagram of the particle, mg is acting in this direction, normal is acting in this direction. So the only force which is responsible for the motion of the particle is frictional force. For the motion of the insect is the frictional force. So let friction is acting, which is acting as a restoring force. So this is the restoring force. Let the acceleration at that point is a. So we can write F is equal to ma and n is equal to mg. Now if I consider the free body diagram of the disk, then at this point the normal is acting in this direction on the disk and the friction is acting in this direction. Since the disk is in the state of rotational equilibrium, so the torque of these forces about this point P must be 0, or we can say they must balance each other. So n into x or mg into x is equal to F into R. The value of F is ma, so it is equal to ma into R. So from here the value of A comes out to be G by R into X. It means this is only possible when the particle is in the state of SHM. So this is my omega square. So omega square is G by R. So if I calculate the total time period of one oscillation, that is equal to 2 pi by omega, and the value of omega can be written from here, that is R by G. So on substituting the value of under root R by G, which is given in the question, 4 by pi, so on solving it comes out to be 8 seconds. So the value of delta t, that is the minimum time from O to B, that is t by 4, so it comes out to be 2 seconds. So the correct answer for question number 1 is 2. Let's move to question number 2. In question number 2, equation of standing waves in a string is given by y is equal to 2 sine 2 pi x plus pi by 4 sine 2 pi t plus pi by 6 centimeter, where x is in centimeter and t is in second. If tension in the string is 100 Newton and energy stored in the region from x1 is equal to 7 by 8 centimeter to x2 is equal to 17 by 8 centimeter is u joule, then find the value of u divided by 5 pi square. So in this given question, if I plot the loop of the standing waves, then this is my x is equal to 7 by 8 centimeter and this is my, let x is equal to 17 by 8 centimeter. So if I substitute the value of x is equal to 17 by 8, then we will find that it is the point of antinode. So if I draw the loop diagram, then it will be like this. This is the antinode and this is the loop. So this standing wave is of something this pattern. So if I write the energy stored in this, so the total energy stored is equal to, so the number of loops is 2.5, so that is 5 by 2, and the energy stored in one loop is written as 1 by 4 mu omega square a square into this length, that is lambda by 2. So if I substitute the data, the value of mu is t by v square. So the value of t is 100 and the value of v, if I solve the value of v is equal to omega by k. So omega is 200 pi divided by k and k is 2 pi. So it comes out to be 100 centimeter per second. so it is equal to 1 meter per second. So if I substitute the value of V as 1 square, then the value of mu in SI unit comes out to be 100. The value of omega, as I have already known, it is 200 pi. The value of A is 2 centimeter, so 2 into 10 to the power minus 2 meter, and the value of lambda can be found out by 2 pi by k, and the value of k is 2 pi. So it is equal to 1 centimeter or 10 to the power minus 2 meter. So if I substitute the data in this equation, it comes out to be 5 into pi square. So u is equal to 5 into pi square. So this ratio u divided by 5 pi square comes out to be 1. So the correct answer for question number 2 is 1. Let's move to question number 3. In question number 3, a U-shaped tube containing a liquid of density rho is equal to 1000 kg per meter cube is rotated about a vertical axis which passes through one of its vertical arms. If distance between two vertical arms of the tube is 1 meter and difference in height of the liquid in vertical arms is 10 centimeter and angular speed of the tube is omega radian per second, then we have to find the value of omega square. So let this a U tube and it is rotated about this vertical arm with angular velocity omega. So due to the rotation, let the difference in the height of the liquid in the vertical column is given h, that is 10 raised to the power minus 1 meter. So this is the difference. Let this separation is h dash. So if I consider this segment, then liquid is filled in this segment. Then the pressure at this point is rho g into h dash, and the pressure at this point is rho g h plus h dash. If I write the force, let this the cross sectional area A, then A is multiplied by this on both the sides. Then the net force acting towards the center is rho g h into A, and that must be equal to the mass of this element, that is rho into A into L. The center of mass is rotating with angular velocity omega, so omega square, and its separation is L by 2 from the axis of rotation. So if I solve this equation, the value of h comes out to be omega square L square divided by 2g. Or from here, the value of omega square comes out to be 2 into h. The value of h is 10 to the power minus 1. The value of g is 10 divided by L, 1 square. So on solving, it comes out to be 2. So the correct answer for question number 3 is 2. Let's move to question number 4. Question number 4. A solid sphere of radius A made of material of bulk modulus B is surrounded by a liquid in a container. A massless piston of area A floats on the surface of the liquid. When the mass m is placed on the piston, fractional decrease in radius of sphere becomes mg upon nba. Find the value of n. So it is given in the question, suppose this is a sphere and it is in a liquid, and this piston is kept on the liquid which is massless, and a block of mass m is kept on this piston. So we know that B is equal to minus dP divided by dV by V. So we know that fractional change in volume is equal to 3 times fractional change in radius. Let A is the radius. And the change in pressure on the sphere due to the positioning of the mass m is mg by A, where A is the cross-sectional area of the piston. So I can write this is equal to mg by A divided by B is equal to minus 3 times dA by A. So from here, minus dA by A comes out to be mg by 3 BA. So on comparison, the value of n comes out to be 3. So the correct answer for question number 4 is 3. Let's move to question number 5. In question number 5, 2 moles of an ideal monatomic gas is heated through a process T square P cube is equal to constant. If increase in temperature of gas is 100 degrees Celsius and work done by a gas in this process is 1000 R by N, find the value of N. where R is universal gas constant. So the given process is T square P cube is equal to constant. From ideal gas equation we know that PV is equal to nRT. So this can be written as P raised to the power 5 into V square is equal to constant, or PV raised to the power 2 by 5 is equal to constant. So if I compare with the polytropic process, PV की power x is equal to constant, then the value of x comes out to be 2 by 5. So the molar heat capacity of the process C can be written as Cv plus R divided by 1 minus x. So if I substitute the value of x and Cv, this is 3R by 2 and it is R divided by 1 minus 2 by 5. So on solving, it comes out to be 19R by 6. So if I calculate the heat supplied to the monatomic gas, delta Q is equal to Nc dt. So N is 2, C is 19R by 6 into dt is 100. So if I solve this, it comes out to be 1900 R by 3. If I calculate the change in internal energy delta U, that is equal to Ncv dt. So 2 into 3R by 2 into dt is 100. So this comes out to be 300 R. So I have to calculate what is the work done by the gas in the process. So from first law of thermodynamics, delta W is equal to del Q minus del U. So if I solve this, it comes out to be 1000 R by 3. So on comparison, the value of N comes out to be 3. So the correct answer for question number 5 is 3. Let's move to question number 6. In question number 6, the intensity of X-rays from a Collis tube is plotted against wavelength lambda as shown in figure. If the accelerating voltage is V kilovolt and value of lambda 1 is 2.48 angstrom, then find the value of V. So from the theory of X-ray, we know that lambda minimum is equal to SC divided by maximum energy of the incident electron. So that is Emax, which is further can be written as SC upon E into applied accelerating voltage. So I have to find out the value of accelerating voltage. So the SC is 1240 electron volt nanometer divided by E into lambda minimum, and the value of lambda minimum can be written as 0.248 nanometer. So if I solve this, it comes out to be 5000 volt or 5 kilovolt. So on comparison, the value of V comes out to be 5. So the correct answer for question number 6 is 5. Let's move to question number 7. In question number 7, if one end of the string is pulled with a speed V is equal to 28 by 5 meter per second, then find the value of V naught. So from the theory of constraint, we can say that the component of V naught in this direction is V naught cos 37 degree. And this must be equal to V. So we can say that V naught into cos 37 degree, that is 4 by 5, is equal to V. So V naught is equal to 5 by 4 of V, and the value of V is 28 by 5. So on solving, it comes out to be 7 meter per second. So the value of V naught is 7. So the correct answer for question number 7 is 7. Let's move to question number 8. In question number 8, two blocks A and B, each of mass 1 kg, are lying on a table as shown in the figure. The coefficient of friction between blocks A and B is 0.3 and coefficient of friction between block B and the table is 0. An external force F is applied in the direction shown on block A. Find maximum value of F in Newton so that system remains in equilibrium. So if I draw the free body diagram, this is block A and this is block B. If F force is applied on this block A, then due to the application of force, relative motion occurs between A and B. So there is a tendency of friction to act in this direction. So from the Newton's third law of motion, the friction on B will act in this direction. The block V will try to move over the horizontal surface. So tension T will come in the string away from the body. So as the tension comes in the string, this T will also act at this point. So at equilibrium, we can say that the value of F is equal to T, and for A, we can say that the value of capital F is equal to T plus F. So this can be further written as 2 times F. And the maximum value of F which can be possible in order to have the equilibrium is mu into Ma into G. So this is equal to F maximum in case of equilibrium is 2 times mu into Ma into G. So if I substitute the data, 2 into mu is 0.3, mu A is 1 and G is 10. So this comes out to be 6 Newton. So on comparison, the value of F comes out to be 6. So the correct answer for question number 8 is 6. Let's move to question number 9. In question number 9, two coaxial rings, each of radius r, having their centers C1 and C2, where C1 and C2 line is along the x-axis, are carrying constant current 4 ampere and 2 ampere respectively as shown in figure. If magnetic field due to rings along positive x direction is taken to be positive and along negative x direction is taken to be negative, then choose correct options. And it is given current in ring 2 and ring 1 are in anti-clockwise and clockwise sense respectively as seen by observer shown in figure. So with respect to this observer, the current in 2 is anti-clockwise, and with respect to this observer, the current in ring 1 is in clockwise sense. With respect to this observer, if I apply the Ampere-Circuital law, then Ampere-Circuital law is line integration over a closed path B dot dl is equal to mu naught into summation I, that is current enclosed in the considered Amperean loop. So with respect to this observer, if I take the positive direction of the magnetic field in this direction, then the positive direction of current is anti-clockwise, because due to anti-clockwise current, as per this observer, magnetic field comes along positive x-axis. So we can say that with respect to this observer, the value of summation I is 2 minus 4. So that is minus 2. And this is equal to line integration from minus infinity to plus infinity B dot dl. So as per this relation, option A is correct and B is wrong. In option C, variation of magnetic field along x-axis may be represented by the graph shown. If I consider the magnetic field variation due to individual rings, then due to ring 2, the magnetic field variation is like this, because the magnetic field along positive x-axis is taken as positive. And due to ring 1, the magnetic field variation is like this, because the magnetic field due to this ring 1 is in negative x direction. So if I consider some point here which is close to ring 2, then at this point the magnetic field must be in positive x direction. But if I see at this point, the magnetic field is negative, so it is wrong representation. Also, in the region between C1 and C2, there must be a point which is the null point, as the magnetic field due to ring 2 is in this direction and the magnetic field due to ring 1 is in this direction. But if I see here, there are 2 points, so which is wrong. Since there are 2 null points and here we have possibility of finding 1 null point, so this representation of graph is wrong. In option D, magnetic field at x equal to plus infinity is along negative x-axis. So if I move to this position at plus infinity, as we have seen, the line integration comes out to be negative. So the sense of magnetic field at this point is in this direction. So option D is also correct. So the correct answer for question number 9 are option A and D. Let's move to question number 10.